So remember, like terms have the same variables, and when you add, you're only adding the coefficients. The variable doesn't change. Are you guys paying attention over there?
Yes.
Mm-hmm. There's always somebody that causes a problem. Usually it's Jaden, but alright, so when we add those two, we just get m to the third. Negative 3m squared minus m squared would be negative 4m squared. And 4 plus 6 is 10. So, I am not going to collect this, so I don't care if you do pencil or pen. You don't have to count it wrong. Just fix any mistakes. We'll start with assignments that I collect next week. Alright. Number 2, what do we have to do there? Distribute. So this would be 24p squared minus 15p. What am I distributing on this one? Good. So that's negative 15p squared plus 10p minus 20. And then combine like terms, so 24 and negative 15 give us a 9p squared. Negative 15 plus 10, so negative 5p minus 20. And you could have those terms in a different order. You just have to have them all, but it doesn't necessarily have to follow the same order I write them. Alright, number 3, what do we have to do? FOIL. So we get 28r squared plus 8r minus 7r minus 2. So combine like terms, 28r squared plus r minus 2. Number 4, what do we do? FOIL. This means you have 2 of them. Oh yeah, if you got huge numbers, you mistakenly thought it was 66 instead of 6b. We're just going over those 5 problems from yesterday. How was the first day at VOTAC? Good. So we get a squared minus 6ab minus 6ab plus 36b squared. So combine like terms, a squared minus 12ab plus 36b squared. Did we get that one? Okay. Last one. Make sure that you guys are paying attention. So you shouldn't have anything else out that's distracting you right now. Also, I have your, I don't know why, but we have too many of these from when we took pictures. I think you must not have, I don't know. Okay. I think December is when I think.
Are you guys in order?
Yes, as long as you have the same terms ordered.
What do we use this?
I have no idea. Just for fun, I guess. Because they didn't tell me we needed them for anything. They just said, hand these out. If you want to prove that you're a student here, I guess. Alright, keep in mind, when you have a negative y, that's to the first power. So when you multiply those, we add the exponents. So we get negative y to the third. Negative y and negative 4, so plus 4y. Plus 12y to the third. Minus 18y squared. Combining like terms, negative 1 and positive 12, so 11y to the third. Minus 18y squared plus 4y. And again, order doesn't matter. So as long as you have all those terms, if they're flipped around, that's not a big deal. What questions do you guys have over those problems? Did we do okay? Alright. We are going to start the next topic now. I did not print notes, so this is your first day of taking your own notes. So get out your notebooks. Don't you dare put trash in my desk. Yeah, I find trash in the desk. You guys will be cleaning them all out, and then we'll flip them around so you can't store your stuff in it anymore.
What if we can just blame Gavin? Yeah, Gavin came, I saw Gavin come over and start with the
Mm-hmm. Factoring is like working backwards. We just got done doing those multiplication problems. Oh, hold on. I just got an email. Student IDs are for entrance into games. Depending on who is at the gate, they may be someone who doesn't know who is a high school student. So hang on to them. Also, some stores and restaurants advertise student discounts. There you go. That's why you have it. I don't know that anybody in town does, honestly, but. So if somebody at the gate doesn't know you're a student, you can show them your student ID. Alright, so factoring is like taking the answer to a multiplication problem and working backwards into what it started with. Okay, we just got done foiling some problems. So if I gave you that answer, can you work back to what you started with? The first thing you always look for when you're factoring is a greatest common factor. So that's where we're going to begin, the GCF. Greatest common factor is looking at what every term has in common. When I look at this problem, how many terms are there? 3. So we're separated by addition and subtraction. So we've got our 3 terms. All right, looking at the numbers, 2, 4, and 8, what can you divide all of those by? 2. So we're going to factor out of 2. Looking at the variables, we have an x squared, we have an x, and this one doesn't have anything. So can we take out a variable? No, 2 is all we can take out. When you're factoring it out, that means it's like dividing. So it's kind of saying if I divided each of those by 2, what would I get? So that first term, you just have x squared. Minus 4x, if you take out a 2, so 4 divided by 2 is 2x. Plus 8 divided by 2 is 4. How do you check your answer to a factoring problem? Yep, if you distribute that back, you should get the original problem. If you don't, then you made a mistake somewhere. All right, take a second, see if you can figure out this one. Only thing that I saw, a few people did. So 6 and 18, we can take out a 6. Variables you have to take out the smaller number, so a squared. Now, when you factor it out, it's like dividing. We took out all of those a's, but what's 6 divided by 6? 1. So don't forget to put the 1 as a placeholder. 18 divided by 6 is 3. We had 4 a's, we took out 2, so 2 left. Okay, that one okay? Let's try this one. Let's throw another variable. So 3 terms, 14, 28, and 21 are all divisible by 7. With your x's, you have to look for the smallest exponent. Same with your y's. So when I take that out, 14 divided by 7 is 2. We had 3 x's, we took out 2, so there's 1 left. We had 2 y's, we took them both out, so those are gone. 28 divided by 7 is 4. We took out the x squared, we have 1 y left. 21 divided by 7 is 3, and we took out all those variables. Are we doing okay with those problems? Okay. So what I want to give you, I want to do another couple more GCF problems, but they're going to look a little bit different than the ones that you are probably used to. But I just want you to get used to the fact that we can use the same principles on problems that are a little bit uglier. When I look at this problem, how many terms do I have? 3. This is 1 term. This is a term, and this is a term. Okay, looking at your coefficients, 24, 16, and 6. What can you take out of all those? 2. Okay, what else can I take out? wants to do the third, the second, and the first. So we can only take out x minus 2 to the first. Alright, so I'm going to use a bracket here. It's the same as a parenthesis, but just helps me kind of distinguish. This is what's left. So 24 divided by 2 is 12. We had 3 of the x minus 2's. I took out 1, so there's x minus 2 squared remaining. 16 divided by 2 is 8. I had x minus 2 squared. I took out 1, so x minus 2. 6 divided by 2 is 3, and I took out that x minus 2. So sometimes it might be an entire parenthesis that you're factoring out, not just a coefficient or a variable. Okay. There are other things I could do on this problem. I could multiply everything out, but I didn't ask you to go that far. I want to put another one up here for us to look at. Now, if I just told you to factor this, you absolutely could FOIL the first parentheses, FOIL the second one, combine like terms, and then factor everything. And you will get the correct answer, but that's a lot of work. There is a shorter option here. If I'm just telling you to factor, I have 2 terms. What do both of those terms have? They have the y plus 1. I'm going to factor that out. If I took it out of the first one, then I have the 5y plus 3 remaining. Minus, if I take it out of the second one, we have y minus 1 remaining. Let's say I told you to keep simplifying this. We can get a better answer. What would you do with that negative? Then if I combine like terms, we're just basically cleaning up inside this bracket at the moment. So 5y minus y would be 4y, 3 plus 1 is 4. Am I done? Is there anything else we can do? This 4y plus 4. What do you notice about that? Take out a 4. Remember with factoring, you have to factor things completely all the way. So if I take out a 4, it's all multiplied, so it doesn't really matter where you put it, but typically we'd go ahead and throw coefficients on the front. So we have the 4, the y plus 1. If I take out this 4, that's also a y plus 1. You can write it like that, or if you get the same parenthesis twice, you know you can also write it as y plus 1 squared. So either of those would be correct. I want you guys to do one. Give that one a try. Good. If you take that out, we have the 5a plus 4 plus the a plus 2. So if we combine like terms, 5a plus a is 6a, 4 plus 2 is 6. So are we done? No. Take that 6 out, so we have 6, 3a minus 1, a plus 1. Right, looked like we did pretty well with that one. So we can do greatest common factor even if it's not just a nice simple problem. Any questions there? The second thing I want to talk about with factoring is difference of squares. We just got done multiplying. We went through that yesterday. And remember yesterday, if I gave you a problem like x minus 3 times x plus 3. When we FOIL that, we get x squared plus 3x minus 3x minus 9. And then when you combine like terms, the middle terms drop out. That happens because these two parentheses were the same, except they had opposite signs in the middle. One was positive and one was negative. And so when you are looking at this x squared minus 9, that's referred to as a difference of squares. Difference because it's a subtraction, and then the x squared and 9 are both perfect squares. And those factor back into what we started with. So remember, when you factor those, it's always two parentheses, one, except one has a positive and one has a negative. Otherwise, it's just a square root. If you have two x's, each of them gets 1. Square root of 9 is 3. So an x plus 3 and an x minus 3. Order doesn't matter, so it doesn't matter if you put the positive or the negative first, as long as you have both. So let's try a couple of those and make sure we remember. You do still want to check. Sometimes problems have multiple steps to factoring. Greatest common factor is always the first. So even if it's difference of squares, you should check for a greatest common factor to begin. When I look at this one, x squared minus 4, there is no greatest common factor. We make sure it's a subtraction, so we can do it. So two parentheses, a positive and a negative. X squared, so you have two x's, each one gets 1. The square root of 4 is 2, so x plus 2, x minus 2. And just like the greatest common factor problems, how would you check yourself? FOIL it out. All right. What about this one? Make sure it's got the subtraction. So what are my parentheses? Square root of 16x squared would be 4x. Square root of 1 is 1. Alright, two more and then we'll probably stop for the day. You guys try this one. X to the 4th, if you have 4 x's, each parenthesis gets 2 of them. One's positive and one's negative. Square root of 16 is 4. But you always have to make sure your answer is completely factored. X squared plus 4 doesn't factor anymore, so you just carry that answer down. And with factoring, we never lose the things we pull out, they stay with it. But x squared minus 4 is a difference of squares again, so that would break into x plus 2, x minus 2. Alright, last one. Thoughts?
Can't work it out.
Okay, why not?
Because it's a close numbers.
Difference of squares, it has to be a minus. If you try factoring this the same, they're all perfect squares. But if you multiply that out, it would give you a minus 4. So that doesn't work. If they're both positive, when you go to multiply it out, so when you FOIL, those middle terms no longer drop and it doesn't give us that answer. So this won't work. What do we call something that we can't factor? That's only if there's absolutely nothing you can do. So if we could take out a greatest common factor or something, we wouldn't call it prime. But there is no greatest common factor, it's not a difference of squares, it cannot be factored, so we just call that prime. Okay, any questions over this stuff? Monday, we will look at trinomials, slip and slide, those kinds of things, maybe some grouping if we have enough time, but I don't want to get into that yet. We only have about 4 minutes, so we'll just stop here for today.